Okay, let's prove that the limit as theta approaches 0 of the cosine of theta is equal to 1. Now we know that the limit as theta approaches 0 of the sine of theta is equal to 0. We just proved that in our last video. We also know something else. From trigonometry, we know we have the Pythagorean identity that cosine squared plus sine squared of theta is equal to 1. And let's solve this for cosine. So we know cosine squared theta is equal to 1 minus sine squared theta. So the cosine of theta will be equal to taking the square root plus or minus the square root of 1 minus sine squared theta. Okay. All right, so now let's go back to our unit circle and look where this would be happening. Okay, so remember in quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Okay. For any point x and y that lies on the circle, remember the x value corresponds to the cosine of theta, while the y value corresponds to the sine of theta. That is if you're on a unit circle, so this would be 0, 1. This would be, I'm sorry, that's 1, 0, this one's 0, 1. Okay, so as we look at these quadrants, what could we say? We can look at quadrant 1 and the x values would be positive. So inside of here, we could say the cosine of theta is greater than 0 for all of quadrant 1. And again, we could say the same thing in quadrant 4 because the x values are positive, so the cosine of theta must also be greater than 0. And really, that's all we'll need to look at to do our proof. So for angles that lie in the first and fourth quadrants, so for angles that go in between negative pi over 2, remember this one's the negatively rotated pi over 2, all the way up to the positively rotated positive pi over 2. Let's see. Negative pi over 2. So any angle that falls in between these, we have that the cosine of theta will be positive. So we can use that identity as the positive square root of 1 minus sine squared theta. And that's all we'll need. So now let's examine the limit. We have the limit as theta approaches 0 of the cosine of theta. Well, that's the same thing using the identity as the limit as theta approaches 0 of the square root of 1 minus sine squared theta. And now we can do, well, we can let's move the limit inside just to do it step by step. The limit as theta approaches 0 of sine of theta, and then we can square that by the limit laws. All right, now we'll do our substitution. As theta approaches 0, 1 doesn't change. The limit as theta approaches 0 of the sine of theta is just 0. We'll square that. That's just the square root of 1 minus 0, which is just 1. Therefore, we can say the full limit, the limit as theta approaches 0 of the cosine of theta is equal to 1.